Hi, I'm Rob Affleck, UX Manager at YouTube ZRH. We recently had the privilege of hosting Don Norman, who visited our UX team to have a discussion around various UX topics. Afterwards, I had the opportunity to sit down with him for a brief interview, and during our conversation, we explored how his pioneering work has really shaped our understanding of human-technology interaction. We delved into his remarkable career journey, from his background in electrical engineering and cognitive psychology to his significant role as a co-founder of the Nielsen Norman Group. Don shared valuable insights and his unique perspective on the evolution of UX throughout our discussion, and I hope you'll find it insightful and enjoyable. So today I'm joined by Don Norman, a leading voice in the UX field. Thank you, Don, for talking to me today.
Thank you for inviting me.
I'd like to start by talking about your earlier experiences in the field. Your path into UX expertise has been remarkable. You majored in electrical engineering at MIT and then went through to establish the Nielsen Norman Group in 1998. What motivated you to bridge the gap between human-centered design and industry practices at the time?
Well, I graduated from MIT as an electrical engineer, as a real nerd. And the philosophy among us nerds was that we could build these wonderful things if only the people wouldn't get in the way. The notion that people were in the way was kind of in the background for a long time, and when I was an electrical engineer. But as I continued my studies, I really wanted to study computer science. I wanted to which didn't exist at the time. I wanted to study computers, and I'd left MIT and I was getting a master's degree at the University of Pennsylvania, where the first computers had been built. But they didn't have anybody teaching computers because, well, they had all left and started a company. Remington Rand Univac, the so-called giant brain of the time. And so what was I going to do? And they said, oh, stay, well, you could be the first graduate. No, I didn't want to wait. I didn't know how long I would wait. When just then the psychology department got a physicist to be the head of the department. And he gave a talk, and I said, oh, I want to build intelligent machines, but maybe instead I'll study this one, the intelligent machine. And he said, you don't know anything at all about psychology, right? And I said, right. And he said, good. And so what I did is I joined the psychology department, but I learned only a little bit of psychology. What I really did was I took all my engineering knowledge and I applied it to psychological terms. And it was turned out to be very effective and powerful. But I still hadn't made the connection, probably, to working with people. And what happened was my first job was at Harvard, where I was introduced to the faculty and denounced. B.F. Skinner, the most famous psychologist of the 20th century, stood up and denounced me in my field, mainly because I wanted to study things that you couldn't see. And he didn't believe in that. And then after Harvard, I got hired by the University of California, San Diego, which was just starting. No one had yet graduated when I joined the faculty. There were just about 100 faculty members at the time. And I still was doing signal detection theory and to study human memory and so on. But I got more and more interested in trying to apply the work because I sort of, as an engineer, I like to apply what I was doing, and I had long-used computers, and I built one of the very first computer-based laboratory experiment when I was at Harvard, and I continued that when I was at UCSD, and we started trying to understand why these were so difficult to use, and I wrote this paper, The Trouble with Unix. And it said it was just a horrible system where everything was inconsistent and it was hard to learn because of that. And that got to the people who created Unix, and wow, were they mad at me. But that actually got me interested in how we could design in a way that was understandable. And for Unix, I said, one of the problems was that the programmers didn't have the right tools. Because when you're doing programming, the exciting part is to do the hard things and manage to make it work. And when you're writing the calling sequence for the routine, that's dull and uninteresting, and who cares? And so everybody would make it up each time, and so they would make it up in different ways each time. Even the same person might use different structure. And different people would use a different grammar, basically. And that's what made these things so hard to use. And also, if you typed on the word processor, which was called ED, I believe, in those early days, and when you're all finished, wow, I finished, and so now I'm going home, so I turn off the computer and go home. And I come back the next day and, where is it? Where is it? And did I save it? Well, no. And ha, ha, ha. Many people make that error. If you want it to be saved, you got to say save. Right. And I said, why is that? Why can't you just save it for me? You don't do any harm by saving it. Right. And anyway, that got me really interested and got me into sort of the field. And eventually I developed a team of people working on this. And I started consulting for Xerox, the Palo Alto Research Center, where they were doing the very first what you see is what you get computers and drop-down menus. And actually, I started teaching this in my courses, and some of my students were the ones who helped develop the software for the first Macintosh. Well, but what really got it was the 3 Mile Island accident happened in nuclear power. And the operators failed to understand what was going on, and they didn't do the right actions. And so it took a long time, and it was really close to a real disaster. As it is, it stopped nuclear power work for 10, 15, 20 years. It's just barely starting again now. And so I was called in because I had written some papers on human error. And I was called in to analyze why the operators made such stupid mistakes. And with a team of human factors people. And what we said was, it's the design that's bad. Right. These operators were very intelligent. They did very intelligent behavior, but the plant, if you would design something to cause human error, you couldn't have done a better job. So anyway, but I realized, design, that's interesting. And gee, I know about people. I was starting to learn about people by then. Right. And I know about technology. Maybe design something interesting. And so I started working with NASA on aviation safety and the design of cockpits and the design of systems. And that's how I started.
That's fascinating. I mean, you have such a broad range of experiences. It's incredible, honestly. Like those experiences today, like with the challenges that we face in the kind of global society, what would be the kind of challenges and opportunities do you think that new designers today would have to make a better world? Like what should they be?
There's all sorts of opportunities. First of all, we're in the middle of a technology revolution, not one revolution, a whole bunch of revolutions in new sensors that can measure things that we never before could measure. We have a revolution in new materials that are lighter weight and stronger and biodegradable. We have new manufacturing methods. 3D printing is just one of many examples where you can create things with holes in the middle so that you can make them lighter and without losing any strength. And you can do things that just were inconceivable to manufacture before. And we have new methods in medicine. And because it uses the new sensors and uses the new tools, and the computational tools have gotten so powerful, and the cameras have gotten so small and so powerful. Mind you, the power of the small camera is aided by AI. Because when the first cameras came out in cell phones, I said they could never be any good, because you're lucky if you get 1 photon per pixel. They're so small. Well, today those are fantastic pictures. How do they manage it? A lot of good processing going on. And so the technology has changed. It gives all sorts of new opportunities. And I haven't even mentioned, AI has been already very powerful in many, many things in focusing your camera and detecting that there's your face, let me see if I can balance out. And maybe I can expose that part of the film or the detector different than I exposed that part. And today, the hot stuff in AI is the neural networks and the large language models, but that's only the beginning. Right. And we're starting to see, look at the robotic work, where it used to be robots. One of them was called shaky because it could barely move and it shook for a long time. You had to wait till the shaking went down so it could process a picture. And today they can jump and do hoops and do all sorts of things. And they're still limited, but they're getting very, very powerful. And in terms of cognitive abilities, that's starting to build. Now, the new GPT, the new AI with large language models, has lots of flaws. One of them is that it's just a pattern match. So it really doesn't understand what it's doing or what it's creating, which causes it difficulties. It's also trained by humans, and humans are biased, so the biases are trained into the system, but we can overcome that. Right. But this is a very powerful tool. I've already been able to use it in very effective ways, and it's fun to play with, and it's in its infancy. Right. So we don't overlook the problems, but we work on the problems to try to minimize or ideally prevent them. Right. And there are just all sorts of opportunities for people. I think healthcare is going to be very important. Yes. Automated vehicles is already important. Right. And will be more and more important. They're still very limited in the weird cases. And yeah, intelligent systems that really, but they will help us do our jobs better.
Right, and I actually read somewhere that like in the future, maybe not too distant future, the AI will be very much like, in the medical sense, your one-to-one doctor, right? Like at the minute a doctor is one-to-many, there will be the future where an AI is kind of your lifelong companion, reading what you need from like a medical perspective.
Well, there's all sorts of reasons why that's going to be difficult. Not for technical reasons, for legal reasons. Right. The HIPAA requirements of safety and confidentiality and so on make it very difficult to share your medical records over time, because it'll be different medical systems and different doctors and different people. But yes, you're right. But this will be a great aid. One of the problems is right now in the medical field is that every physician writes notes, but the pile of your history is huge, and no one has the ability to go back and read it all, and they're written by different people or different. But what we can do is, if this was fed into basically a large language model, then I could ask it questions. I could ask, well, I see this, you have this problem today. Has that occurred to you before? But you may not even remember whether it has, but the system can go down and say, well, yeah, I see, and I look at the blood sample that we did 10 years ago, and there seems to be a hint of the problem you have now.
And what do you think, as a designer in the UX field, will be some of the challenges working within this new Gen AI landscape?
Because what we want is, we want a partner, we want a collaborator in solving your medical problems, and both in the language that the physician understands and also in a language that the patient or the family understands. And I think AI is going to make life easier for the physician, just as I said, in reading the history of your medical records. And for that matter, after I've seen the physician, they have to spend quite a bit of time to write up their notes. But why not have it dictate or watch over the interaction and do a quick summary? And then the physician could annotate it, and maybe, of course, it won't be quite full and quite correct, right, but it makes the physician's job much, much better. Right. And as you said, one of the problems that often happens at home is there's some problem, and it almost always happens in the middle of the night at the beginning of a weekend. And I don't know whether it's serious or not. Right. But if I can ask a system, and I've already tried to build systems that do this, so using good old-fashioned AI, we can do that a little bit. Have it narrow down and say whether I should really worry about this and go quickly to the emergency room, or whether, no, calm down. Here's what you should do. Take this medication or do this, and it'll be tomorrow. Let's look again. Right. And AI will be better at that. Right. AI is already better at reading basically images and detecting cancers, detecting problems, than the average radiologist. Right. And the good radiologists that I've talked to about this, well, that might put you out of a job. And they say, oh, wonderful. I had to sit in this room and watch images all day and boom, 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 boom. And this will relieve me of that job, because that doesn't really use all my medical knowledge. And I can go back to being a doctor, and I can use my medical knowledge to treat the patient based on what the system has told me is happening.
Right. Yeah, I mean, there's so many possibilities in this space, and also possibilities for misuse as well, I would believe.
Yeah, but name any issue that doesn't have the misuse problem.
Correct. I mean, all emerging technologies have this problem.
Pencil and paper.
Right. Yeah.
What I write can be badly misused,
Right,
or I could be writing nasty propaganda, et cetera, et cetera.
Right. I mean, obviously that is one of the problems about kind of misrepresentation of people and so forth. And one of the things that I think society as a whole needs to really think about how we are going to sort the real information from the false information going forwards. And so it's a fascinating problem to solve.
Well, I think we will solve that. I think one of the problems is, as I said earlier, these systems do not have any intelligence, basically. They don't understand what they're doing. But we can build some understanding systems on top of it. And also we have to have a lot of checks and balances of all sorts, because I want them to be my assistant. But you know what? When I have a human assistant, they have these same fallacies. I ask them to do a job and I explain it in great detail and it comes back wrong. Right. It isn't what I wanted at all. Didn't you hear me? And so I have to train the assistant and learn how to explain it better and so on. And also the assistant gets more and more skilled as they do this over and over again. That's going to happen with our AI systems.
Right. Bringing it back more to a general UX focus now, what, in your opinion, are the key principles of intuitive design, which obviously you're so well versed in, and how can they be applied to the UX design process, in your opinion?
First of all, I don't believe in intuitive design, because you know what intuition is? When I do something subconsciously, and I'm not even aware of how I did it, and that took me to do things well subconsciously. It can take years and years to get that skill. And now, when we drive a car, if you've been driving for a long time, it's done intuitively, right? I drive in this and so on. But when you tried to learn to drive, you couldn't believe anybody could drive, because I have to handle the clutch and the accelerator and the gears and the steering, and don't forget to signal and look to see if there's a traffic light, look to see if there's traffic, if there's any pedestrians. How can you do all of that at once?
Right. I think mainly intuitive design in my mind is like, say, the smartphone or, the door handle, something that you just know immediately how to use. And
well, because there are some fundamental principles that guide our behavior, which I've written about at great length. And that just requires a good attention by the designer who understands people and makes sure that there are signals, I call them signifiers, that say, this is where you should do the action. And what kind of an action? Well, it also has to apply that certain actions are possible and others are not. And some of the systems we're designing today, where there are hidden gestures, you have to learn to swipe down this way or that way from this location or at this speed or whatever. No.
Right, like a long press on a phone, for example, is a very hidden.
So I can do a short press or a long press or a double press This is crazy.
Yeah.
But it's just bad design. It's clever, and so a lot of the programmers love clever things, and some designers love clever things. But cleverness, at the cost of making things almost impossible to learn or to see.
My final question for you, and thank you so much for your time. It's been a real privilege talking with you today, is what advice would you have for someone who's just trying to start and establish a career in UX? What advice would you have for someone like that?
That's complex, because the term UX, user experience, for me, when I helped develop the term and use it, it was all about, I want to really make the entire experience of learning about something, getting it, unpacking it, getting it started, using it, just be wonderful, delightful.
Right.
And today it often means, I build a website or something simple. But the challenge in starting as a designer is you have to learn to be a team player. Right. And when you first start, you're a junior person, a junior team player, which means your job is to learn and to assist and to help. And in doing that, you'll probably make many errors, but that will turn out, those are very valuable in your learning, because we learn from our mistakes, and we learn a lot from them. And it's important that you actually, I learn a lot by doing stupid things and doing the wrong things. And I keep learning because I keep doing stupid things and the wrong things. But the important point is not that I'm making errors, is that I'm make sure I try hard never to make the same error twice, because I'm learning from it. And what you need as a junior member of a team is to be a team player. Right. And people can learn to trust you, that when you promise to do something, you actually do it. If you're not capable of doing it, you say you're not, or maybe you say, why, maybe I'm not sure I can do this. Could somebody help me to get started? So you have to be honest about your abilities and also your lack of abilities. Right. And because eventually people will come to trust you, that you don't promise something you can't do, but you do promise things and you deliver them on time and schedule. And that lets you move up in the company, and that pretty soon you'll be given more and more difficult issues to solve, and pretty soon you'll be asked to generate your own issue, or maybe your own product or your own idea. But you have to earn that right.
Right. You have to earn the trust to be able to do that, right?
Yes, you have to earn their trust. And of course, your own abilities have to increase, but that will be automatic as you're learning and working in the company.
Yeah. Well, thank you so much for talking with me today. As I mentioned before, it's been a real pleasure. Your wealth of knowledge is just incredible, and
yeah, well, I'm very old. And that helps. You learn a lot.
No, but the amount you've committed to the UX community has just been, kind of unparalleled. And designers like myself use your knowledge every day, so it's just been a real pleasure talking to you.
Thank you.